the next process here for the 12 volt wiring is we have all of the bus bar and everything like that you saw, but now we need to power all of the lights and all the little things, right? So we're gonna run wiring from these bus bars up over around this. It's come down here, and then these are the two small little fuse blocks that we got for I think like $2 a piece. It was pretty ridiculous, maybe $4 a piece the maximum. And they have covers, and these are for regular like ATO I think fuses. You'll see. So we're gonna mount them right there, and the wiring is gonna come down like this and in. Then so for the mounting holes, this is pretty thin sheet metal. I don't even know, 20 gauge maybe, something like that. So right here we're gonna use these. I call them nutserts. I think it's a threaded insert. So it instead of just running sheet metal screws in there, this is a better, more removable. You'll see. It's just better. It's a nutsert. That's what I call them. So to do nutserts, first you need to drill a hole. So we're gonna do that right now because you're on there. This is a pilot. Now this is the correct size drill bit for these are 1032 nutserts. So you can just go look at the chart. Alright, so there's your hole. Then your nutsert should slide right in there, which it does. So this is the manual tool that you thread on there all the way. Just like that. You put that right in there. 9/16 in this case. Throw that in. Then you take your Allen and you start cranking her. And right now it's squeezing it from the back side. We're just going to tighten this down and crimp right onto the material. Hopefully it's not too thin, which it feels like it is. No, it's not. Okay. That's pretty tight. Now I'm going to back it off. So now that we got the one nutsert in, take your 1032 screw, put that in there, and you thread that in. So we got to do the rest of them, and it's a much better connection. You could take them all down, and you could just reuse it. It's not going to wear down the sheet metal if like sheet metal self-tappers or something. It's a much better system. So and look, it's pretty much flush. The inverter output of the AC side, 10 gauge wire going into the panel here. It's the wrong cord, so it's a little thicker insulation, so I had to give it the old spit lube this time. Alright, got that done. Illegal! Illegal! Music! Shut her down! We are going to do a real world test here for the inverter running at full capacity with the with the breakers that I got. We have a 15 amp main and then two 15 amps that are fed by the main, obviously. So they're on their own circuit. Oh, they are their own circuit, but they're all going through the 15 main. So I'm going to run two hair dryers at 15.5 amps. On high, on medium, 1.9 amp. So those two run together equals 15.5 amps, which is the limit for the 15 amp breaker, but sometimes they can run for a long time before they actually trip when they're right at 100%, so or near it. So let's see how hot all the cables get and how many amps we're pulling. Okay, ran it at 15.5 amps for 42 minutes with both of the hair dryers running, and it did not trip the 15 amp breaker. I didn't think it would. The battery cables they're warm, but they're not hot. No danger zone here. And we got the charge down to pretty much 50%. The battery voltage is at 11.8, which is lower than I would want to discharge it to. You know, the less you discharge, the longer your batteries last. And everything worked out. The low voltage alarm started going off on the inverter, and I have the alarm set to start alarming at 55%. That started going off on the battery monitor, and now it's saying to charge. So everything worked as it should have. As long as you're in the camper, you'll know that you gotta charge it. Stop using the inverter or the batteries. Some of these updates, as you can probably already tell, the clips don't match up because things were done in not the order that you're seeing them, because I just did things as they needed to be done. To make a video one topic, it's kind of difficult because I'm working on a little bit of a lot of things all of the time to keep the way that I'm building this camper and around the horn here it's difficult. So I figured I'd just show an update of where I'm at, just like a generic update, because it's more than the electrical system here. I mean, we got walls were up, you saw that in the last video, but there's a lot of things that have happened that they're little things that's not worth putting a whole video together for. So electrical is by far the most things I've gotten done. This spaghetti mess here is just because all the wires are going to be tied up at one point to the bottom of this countertop. So disregard all that. The positive bus bar and the negative bus bar have their wires coming off of them for the 12 volt DC side of the things in the camper. Got two light switches mounted, got the Victron Energy BMV 700, which is the battery monitor, which you've seen me reference a little bit. Got the thermostat, seen that in other videos, but she's mounted. This is the remote switch for the inverter, and all of the necessary wiring in the back, which is just time consuming. That's all. It's just time consuming. It's not completed, but this is all drilled through here and then comes out on the other side. I'm going to put a little false wall, or put a little wall to hide all of that eventually, because that's the closet. And all of those wires you just saw come out right here, and these are all looped. You can't cut them, you got to leave them that length, so they're all looped sitting here, and you know, it's just a lot of stuff. So there is the AC panel. So I didn't show all of this, but what it comes down to is a 15 amp main and two 15 separate circuits throughout the camper. So I found out that the best scenario for what breakers I can get is to put a 15 in the main. It takes over 20 amps for about 40 seconds or something like that. I did a bunch of tests for that breaker to pop. The overload was going off on the inverter, and it eventually did shut down, but I don't want to rely on the inverter's overload protection to shut it off to you know, protect the whole system. I want those breakers to pop. So I know that I'm limiting the AC power that I am capable of using in the camper. If I'm on shore power, I could run a full 30 amps with that inverter. Now, that being said, when it's on inverter mode running through the batteries, it's 2500 watts, which equates to about 20 amps. Okay, that's what it'll run. That right there is 15 amps. But that 15 amp breaker will pull 28 amps for 45 seconds, things like that. We'll put it this way, that thing was overloaded and just alarms were going off and it was shutting off before, when I had a 20 amp breaker in there. It would not pop that 20 amp breaker. So I had to put a 15 amp breaker in there in order for this breaker to pop before the overload started going crazy and the overload started shutting down on here. I want that breaker to pop because that's easy to just, you know, it's a very safe system. And 15 amps in this, it's a camper. That's a lot of power. If I do need to run a 30 amp service and I'm plugged into shore power somewhere, I can rip this 15 amp breaker out and put a 30 amper in it. I mean, it's that simple. It's not something, it's not ideal, but it's one screw, two screws if you count the cover. So this is what we got. There's the DC side of them. There's your little fuse block. The AC side of this of this build is certainly not done. I have one, so I did wire, that's what this Romex coming out is. I did wire for the fridge. So you're on the outside of the camper now, that Romex wire comes up and goes over around and then comes back down and goes into this receptacle for the fridge, which I shortened that line there to make it nice. It was like a 4-foot cord for a 10-inch area. And I got the 12 volt side done. Everything's done. Gas line's done. The fridge works 100% on 3-way.